So this is the previously modeled building, and now we will define the seismic loads. We have to select IS 1893-2002 and click add new load. Now we have to modify the seismic loads. So we are selecting motion both x and y direction and assuming there is no eccentricity. The problem statement states that the building is located in Bangalore. So Bangalore is located in a seismic zone 2, which will be having the seismic zone factor as 0.1. We are assuming medium soil and therefore site type is 2, and we are assuming residential buildings, so importance factor is 1. This is an ordinary moment resisting frame, so response reaction factor is 3, and time period we set it as program calculated and click OK. So now the seismic load is defined, so we have to go and check the load combinations. So all the load combinations are already loaded, so we give OK. And now it's time for analyzing. So since we are doing a seismic design, we don't have to run the wind analysis, so we select the wind load and check do not run case, and now we give run now option. So this is the deformed shape showing displacement of each joint. We can move the cursor over each joint to get displacement, translation, rotation, drift of each joint. Now it's time for designing. Make sure it is IS 456-2000, and now we start our design and checking. So we are going to retry the analysis and design for the 11 frames that have failed. So we have reiterated the analysis twice. This has to be fine by now. So we will verify the check. So this shows the reinforcement detailing of each frame. So now we will check our design, verify all members passed, and we get the dialog box saying all concrete frames passed the design check, so the design is safe. Now we can move on to the response spectrum method. So we need to make sure seismic load is added. Before that we need to unlock the model. So we need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Before that we need to unlock the model. We need to make sure seismic load is added. Bef We can delete the wind load as it is no longer needed. We are doing seismic analysis alone. Everything is as per the previous data. Now we have to define the response spectrum function. We have to choose IS 1893 2002 and click add new function. Since Bangalore is located in a seismic zone 2, the zone factor is 0.1 and we are receiving medium soil, so soil type is type 2. Damping ratio should be selected 0.05 for concrete frames and 0.02 for steel frames. Now click OK. OK again. Now we need to define the load cases. We have to add new case. Select load case type as response spectrum. And scale factor is 1633.5. Scale factor is given by the equation Ig by 2R, where I is 1, G is 9801 millimeter per second square, and R is 3. Since we have given the direction as both x and y, we need to define two load types, two acceleration along x and along y. Directional combination type is CQC3, model damping at 0.05, and give OK. Give OK again. Now since this is the response spectrum method, we don't need to analyze the dead and live load, so set it to do not run and click the run now option. Now the analysis is carried out without analyzing the dead and live load. So this is the deformed shape of the building. So now we can design the building, design the sections. This option will automatically design and check all the frame sections. So we are reiterating the analysis and design for the 8 frames that actually failed. So we are getting the reinforcement details of all the concrete sections, and now we can verify whether all the members are satisfying the design check. And yes, all concrete frames are passing the design check, so the design is safe. Now we can move on to the third step, that is the time history method. So we first go to the load patterns, and we have to slightly modify the seismic load. Before that, we need to unlock the model. We are modifying the seismic load as we have only the data corresponding to the x direction of the Bhuj earthquake, so we are selecting the x direction only without any eccentricity and click OK. Now we need to define the function, time history function. We are selecting from a file, so we need to select from file and add new function. So we have selected the data file corresponding to the Bhuj earthquake, and in order to fill this field we need to first view the file. So we need to skip first 9 lines, and we need to consider only 1 point from each line. So give 9, and number of points per line as 1. Rename the data. And click OK. Click OK again. Now we need to define the load cases. We need to add new case. Before that, we can delete the response spectrum as it is no longer needed. We are doing the time history method. We need to select the load case type as time history and linear model type. We need to add the load pattern as acceleration. Function is time history, and the scale factor as done before 1633.5, as scale factor is 2i is ig by 2r. Model damping should be constant at 0.05, and we go, there is need to take only one load supplied option because we are considering the direction along x-axis only. Now it's time for analyzing. Set load cases to run. So already the dead and live loads are set into do not run action, so no need to change that, and now we can run the model. The analysis is underway. So this is the deformed shape of the building, and we can get the details information regarding joint displacement by placing the cursor over the joints. Now we can design the building. View the preferences and make sure it is set to ISO 56. Now we start design and check. So we have the final reinforcement of each section. We can right click to get the details and click OK. So the analysis is complete and we can verify the design. Yes, all concrete frames pass the design check, so the design is safe and the design is over.